Okay, so we have seen a lot of things inside Unity. Now we will be seeing scripting, how scripting works. Right? So we have scripts inside of this folder. I will tell you everything about how scripts work. So we are opening a script. So now this is actually a namespace script. You can see that these are the namespace using Unity Engine, Unity Engine.audio, namespace, Unity.sps game. So this is actually a namespace which we have created ourselves, but is not provided by Unity, right? So this is a public class. This is an access modifier. So access modifier of various types: public, private, and protected. So as you can see, if I make it protected, it gives me a red line, right? It gives me a red line. Because it's protected, it won't really, C# won't allow this class to be inherited. You can add access this class outside this, but any public class cannot access it as long as it is private or protected. But if I make it public, you can see that it does not give me the red sign now. Right. So this is the function of access modifiers. So we give access, then we have three types of access: public, private, protected. This is the class, and this is the class name, audio utility. Now we have done it static, right? So this has become static here, and if we go into different classes, you will see that this is actually a conditional operator. This is actually for Unity, like this hash. It's actually an if and else statement, but for the Unity editor. If you can say, if it is inside the Unity editor, this function will be run. If it's not inside the Unity editor, this will be run. If inside Unity editor, this will be run. If not, this function will run, which is nothing. And if nothing. If it is inside the editor, this will run, otherwise it won't run. So these are the operators that we use for debugging inside Unity editor. Right. Now I'm gonna tell you this is actually a public constant string. So it has, this is a class where we have provided provide all of the game constants. I will be telling you about the design patterns as well. First, you will be seeing how scripting works inside the Unity. I will tell you examples. I will tell you example scripts for you to understand. Right? I'm doing it this way because you can see things and understand it better using examples. Right? So we have now we have this int. bool. So these are actually, these, this is how we define things in Unity. So let's say I create public print material, or let me name it Unity only, Unity AS semicolon. So it was giving me an error because I did not have a semicolon, so it was a data type, right? So I have a string. So I am defining public access modifier string data type Unity AS is the string. It is the name of that data type, and we can define it like we have defined it here. Public integer submash index is the name of of this data type, and the value is 0. Now if I put it to anything, generally again, it won't give me an error, but if I put it to 0, it will give me an error because the data type here is string, but if I make it integer, it won't give me an error because the data type is integer, it won't give me an error. But if I make it float, it won't give me an error because float allows decimal formats. So float is actually you know integer type. So if I make it decimal, it's still giving me an error. Right. Sorry, my mistake. Float. We have to put the S here. Right. So it's as you can see, it's not giving me an error. So this goes for every data type inside of Unity. There are various data types. I'm gonna type it here. Data type. Sorry, I use it. Data type. So there is data type int, bool, and we have float, and we have string, then we have, yeah. So these are the main data types, right? And then we have list and dictionary, which is kind of an advanced concept, but we'll be mostly playing with these data types only. So as you can see, I'm not having an error here, but if I make it cool, it will give me an error. I have to make it string so that still give me an error. So it's not existing in current state. Okay. So we have not defined it here, right? We have not defined it here, that's why it's giving me an error. Right. So this is actually public game object prefab, target prefab. These are the name of the public game objects. You can drag and drop a prefab here. This is the source prefab. This is the target prefab. This public game object will be available in the editor view, right? So I know about this, and I will be telling you about the inside the editor as well. These are the public access modifiers. Let's say I have CSS data, right? Data is part of the system level. These are the public, you know, this is coming from the script and we have made these things public. As you can see, if you leave it here, grid extent, grid resolution, grid preview. So all of these were made public. That is available and visible in the Unity inspector. If I make one of this private, it will go away. Grid star, I made grid center private. Right? It's loaded. Grid center has been gone. Right? Because I made it private. Now, if I make all of them private, save it, all of them will be gone. Right? So this is how access modifiers work. We give access inside of the code to let Unity know that this needs to be shown in the inspector or otherwise not. And it's actually for our debugging as well. You can make it private if you want, and you can decide it inside of code. That's not an issue. I made all of these public so it will show up again. Right? It's still loading for some reason. Yeah, it's available again. Right? I can design the coloring. So we will be seeing different scripting techniques that we can use. There are some design patterns inside of Unity, right? So I will be telling you, actually these design patterns are not just for Unity, it's used everywhere else. So about C Sharp, I'm going to tell you about C Sharp. So mostly inside Unity we use C Sharp. There was a time when Unity script was being used. It was actually a version of JavaScript and Bolt as well that we used to use. But nowadays Unity is a popular game engine and we mostly use C Sharp as its scripting language. So C Sharp is an object-oriented language that is used to create scripts in Unity. So Unity scripts are attached to game objects in the scene like we saw just now. Right? Let me show you again. So this is actually a component. The script acts as a component that are attached to game objects in the scene and they define the behavior of these game objects. For this example, this game object, this level behavior will be defined by the script, right? So, sorry. C Sharp scripts in Unity are compiled at runtime, which means you can modify and test your codes very quickly, right? And some specific behavior of Unity for C Sharp is so Unity C Sharp is also used for .NET frameworks, but for Unity we have some different applications of C Sharp. So that .NET framework C Sharp is different than the Unity C Sharp framework, right? So the base class for all Unity scripts is mono behavior. It provides access to Unity's functionality such as physics, rendering, and updating. So if I play this and the update loop that runs inside of this game that is provided by Unity, and it's not that we code it ourselves. That is actually provided by Unity by the mono behavior, which is the base class of all Unity scripts, right? The game object is actually a fundamental object in Unity which can have components, scripts, and children, and it's very useful for making a game. So all of these things that I'm playing this game, I can see all of these things. Even the bullet coming out of this gun, this health bar, this even the camera, enemy, all of this is game objects. So game objects make up our space, right? If I show you in the hierarchy, all of these are game objects. Everything is a game object inside Unity, and it's very crucial that we know, sorry, that we know the basics of game objects in Unity to make compiling, to make a attractive game, right? So components are reusable piece of functionality that can be attached to a game object, such as script and such as a render, collider, or a script. It can be anything. Just like we have this mesh component, a mesh combiner script. So this is a component. All of these are components. Colliders are components. The physics are components. Right? The rigid body is a component. So all of these are components, and this is attached to a game object to give it a functionality, and they are usable. You can reuse them, and this used for colliders, scripts, and everything else. I can give you an example. It is used for audio, effects, event, layout, mesh, miscellaneous, navigation. Miscellaneous comes under game constants and various other things which does not have a category of its own. But we have physics 2D, physics, labels, rendering, scripts, time map, UI toolkit, UI, video, new scripts, basically creating a new C# script, mono script. So all of these components, all of these things come under components, right? So scene is actually the top level container for all the game objects. So this is the container for all game objects. We have discussed this, right? This is the thing. And C# has different concepts in Unity. So C# classes are used to define custom types in Unity, and objects are instances of those classes. The pillars that C# has one of the pillars is inheritance. Unity scripts can inherit from each other or from mono behavior, which is actually the base class. So we inherit everything from mono behavior, right? And like I've shown you, all of these scripts are inheriting. We are inheriting here. So there's a namespace. We don't inherit in the namespace, right? Because we are creating this as a for using in for making a namespace. We are actually making this. This is a namespace that we have created, and we will be using it here, like this Unity, using Unity engine, right? If you get references of this, so that you can see namespace Unity FPS game. We have created a namespace here, and we are using it here, right? So we custom created this namespace to use it inside of this script called ammo controller, and we are using this namespace at various places, right? We will be using unity FPS, unity FPS, unity FPS. So there's a namespace that we have created ourselves, right? Right. So, and if you search about mono behavior, or let me quickly see, this is the mono behavior. We are this class, this public class, is inheriting from this mono behavior super class, and this goes for all the other classes, right? Even the ones where we are using Unity FPS mono behavior, right? So this is the base class, is super class, and mono behavior, which allows for code reuse and a more organized architecture. So it also supports something called polymorphism. Polymorphism is like sharp methods can be overridden or overloaded in Unity scripts, which enables more flexibility and customization. And then we have event and delegates. Unity uses events and delegates to handle communication between scripts and components. So Unity specific C# context comes under these namespaces. This namespace is a C# Unity specific syntax, right? Using Unity engine. This namespace provides functionality access or provide access to all Unity's functionality, and mono behavior is the base class. Void start is actually a method that is called when the script is initialized. So you can search for that here, and you will see that how you void start. So we have void start here. So this method is called when the script is initialized. So this method is called when the script is initialized, and along because this file of code is inside this method, right? So this will also be called when the script is initialized, right? And this will be called when the script is destroyed. Right, then we also have something called void update. So this is a method that is called every frame. Update is a method that is called every frame and used for updating game logic. So this function will be called this method will be called every frame, and this code which we have written inside void update will also be called every frame, right? So this thing will be called every frame. The current ammo ratio will, these things that we have written for ammo movements and getting physical bullets and etc. And if you create a C# script, a demo C# script, new behavior script, you will see that it gets made in the default settings, and it already has start and update return, right? Let me open that script. Actually, I think it should open that. So this is the default script that Unity creates inside the Unity editor. So this is a default C# script, default Unity C# script. Unity default C# script. Right. And we can name it here as well, the new behavior, so that it gets attached to a game object, we need to have the same name. And then we avoid start, avoid update, things that I already told you about, and this actually comes pretty handy for everything, you know, for for various functions, for various functionality. Can we write debug.log? Debug.log is something be which is used to print messages there. Right? Let us clear this game. I don't have any console. Right? But as I go to clear this and right, I will add a function here. Debug.log. Oh, we did not attach it. Right. We did not attach that game object, that script here. I have to rewrite it. Or I'm gonna copy the default user and then enter. Paste it here. Default user. Default user. Hey, attached. Now you can see that game is running. Debug dot unity log is being shown. Game is running, and it will be shown every single day. Now, as I move forward, or as the game goes up, you're seeing this 1500, 1600, 1700, 1800. So this is actually the frame rate that I am going on as as I play the game, and as far as I go in the game, this number will only go up because the frame rate will only go up, right? This is also a frame, and the frame rate which is being rendered. All of these are actually static images because which is being rendered. So this frame rate will only go up, right? So this is a function which is called every frame rate, and I think you have understood what I mean by that. I'm going to copy paste it here, and so you have already seen you have to attach a script to a particular game object inside the scene, right? Like I attached this Unity C# script here in a game object to make it render, like no, to call that script. So I have to attach this script to a game object to initialize this script. Right? Now you can see game has started. Now you see the difference between this. The game is started is called only once the start function, this start function, void start function is only called once. Now you can see this is being called only once and this is being called every frame. So as we started with one. Clear this. This both started at one, right? But game start, this function void start is only called once in the entire Unity life cycle, and void update is called every frame. So yeah, as you can see, we both started at one, but it's going at 1200 right now, and it will only go up as we go inside the game and play it, because the frame rate will only go up, right? So this is the function, this is the update function. But there's a problem with this, right? Let's say my game is working at a 60 FPS, my monitor is a 60 FPS version, so the frame rate is 60 FPS. And I have a monitor which is actually 120 FPS, right? So now there comes a problem where the physics calculation and everything in a multiplayer game is a problem, because it will be played differently on different platforms, right? From if we talk about mobile platforms or monitors or even different monitors will render the game differently. So this is an issue now, right? This is an actual issue for us now, that we have to make critical game functions or critical game logic frame rate independent, so that it does not lag on different monitors and different platforms. So this is where void fixed update comes in. It is a method that is called every fixed frame rate, frame per frame, and it is used for physics and simulation, so that if I'm falling or if I'm shooting a gun, is uh, that thing is actually similar on different platforms. It does not lag on one, and it does not be very fast on the second, right? So to make it frame rate independent, we use fixed update. This is actually an interview question, and it's actually a very common interview question. So keep that in mind. So some of the best practices that we have for C# script is keep scripts organized, use folders, namespaces, and meaningful names to keep your scripts organized and easy to find, like we have done here. Right? We have organized this so very well, right? And the scripts are also organized very well, and we are using namespaces to keep it in a flexible structure, right? So use inheritance and polymorphism, take advantage of features to create reusable and flexible code instead of writing very long code and messy code, which will actually hinder, hinder your performance, hinder the game performance. So to take advantage of C# features to create a reusable and flexible code. Right, optimize performance, use Unity's built-in profiling tools to identify performance bottleneck. Right, there's a tool called Profiler where we actually use it to, you know, see the optimization of the game. I'm just gonna show you how it works and how you can see. I'm not gonna define it right now because this comes under optimization, which is a topic itself in Unity. I'm just gonna show how we can optimize it and how it works. So these spikes are actually the spikes which CPU or GPU uses. So spikes in this graph is actually the usage graph. We are using more as the spikes comes. Right? So we can also write test scripts and iterate on your code. You can do this to ensure that it makes and works as intended. Right? Always refer to Unity documentation, even professional developers and developers who have been here in the industry for like 15 years and even since the inception of Unity still refers to the Unity documentation. The issue with the coding is it gets updated on a regular basis. Like you get out of date very quickly. Right. So to remain in the industry, you need to be aware and update it regularly, just as you update your app and your software and your your phones and MacBooks or whatever device you are using. So be updated for that. And the Unity documentation, the official Unity documentation provides very extensive resources for on C# scripting and including tutorials, API references, and best practices. You can use the question answer platform where you can ask, answer, and questions related to Unity and C#. And there's also C# documentation provided by Microsoft, which is actually a very comprehensive resource for learning the language. So this is actually the basics of Unity and C#. Now we'll be talking about variable types and data types. C# is actually very modern and very object oriented compared to its predecessor, right? Compared to C. And it was actually developed by C#. It was actually developed by Microsoft. Sorry, I mixed it up. And the basic elements of C# is variables and data types, one that we talked about. So variables is something which stores value in memory using a name and a data type. Data type we already saw, integers, booleans, strings, etc. Those are the data types, right? And then you also have operators which actually have a very crucial role to play. Operators such as plus, minus, and hash, and divide operators, and operators, and the star operator, which is used for multiplication, double equals to, and not operator, exclamation mark equals to, and logical operators, assignment operators. So these are various operators that you need to know about. Controlling flow of C# scripts. You can use if else switch statements to control the flow of the C# script. Let me show you some examples. So it is actually basically a SNL statement. So what we do is This is a switch case, right? Now, if this thing does not work, we switch to this case, and if I shoot, the case breaks. We switch to AI state, the case is this, and the default is this, and it breaks after this thing has finished executing. So this and loops also, I think you must be aware, if you are from a coding background, you must be aware of loops. You know, for loop, do while loops, and jump statements. So this is actually the jump statement. Break is a jump statement. Continue return is a jump statement, right? Then we have functions, methods, blocks of codes that perform a specific, task. The perform a specific task for a specific file of code. So you specify the type of a value a method returns. So these are the return types you have defined. Parameters, the values that are passed to a method. You pass something, you pass a value to a parameter. And classes and objects. Classes and objects is actually a very important concept because all of these scripts run on classes. So classes are defined, they define custom data types and behavior. Objects are instances of those classes. Constructors are special methods that initialize objects, and properties are the members of a class that provide access to a data. So this is a class. Oh, sorry. We are on the namespace script. Moving on to the class script. This is the class script, right? And these are the public access modifiers, public, private, protected. This is the class. This is the class name, and this is the thing that we used inside that class, right? Namespaces I've already told you about, and directives. Using directives, you can import namespaces to use their types, and these are the fundamentals for building a strong foundation in C Sharp and Unity. And I think I've covered almost all of it. Yeah. So construct and event and delegates. I will tell you about event and delegates. Event and delegates is like you know it's basically a listening structure, right? So if you think about it, we we promote or we use loose code which is not tightly bound. We want flexible code so that there can be further development in the game in the coming years. So the more loosely it is bound together, the better it is for the other developers to come and iterate on it. Because if you if you look at a code after 6 months, you need to know what you wrote. That's why we have comments here. And even after comments, we need suppose some functionality is being broken because the code was very tightly bound. So we always use techniques to loosely round the code, to reduce dependencies on the code. And I forgot about comments. Actually, this is a comment, and comment is actually used to tell you about why you did what you did. So we wrote this code to fetch components from the same game object, right? And you will find this comment everywhere: landing, all damage, for the ground state to false, and starting, land as like crouching. So this is actually a very good method of writing your code, documented. Not only your code is documented, it's actually structured in a very good way. It's easy to read, right? It's easy to read this code. You don't have to figure this out. If you can just read this comment and you will figure it out what does. So what it does is tell the weapon transit to switch to a non-existing weapon in order to lower the weapon. So you don't have to. Also, it's very clear here that switch to weapon index -1 through, but you don't have to read the code because you can read the comment and it's very properly documented, so it saves a lot of time not reading the code, right? So event delegates are a fundamental concept in Unity in C Sharp that enable loose coupling between objects, the one that I was talking about. So we allow them to communicate with each other without having a direct reference. This is particularly useful in scenarios where you want to notify other objects about changes or events occurring in your application. Right? Now, if you tightly bound your code and if it's not using events and delegates, suppose that piece of function or that piece of code needs to be removed. So you have to do it so you have to remove it everywhere. If you are using events and delegate and this loose coupling between the you know between the game objects, it's very easy to remove that particular piece of code. So an event delegate is a type that represents a reference to a method with a specific signature. That's actually a way to decouple the object that raises an event, right, from the object that handles the event. So it actually separates the object that raises the event. Suppose this is the object which raises the event, right? And this is the object which handles the event. So both of these are separate by using events and delegates to separate them to promote loose coupling. So declaring an event, to declare an event, you use the keyword followed by the delegate type and the event name. So search the delegate. So delegate, right? So this is how we define it. We actually use it in a different way. Mostly we define it like public delegate void. Maybe using new behavior script that I created so that it does not go and mess around with the. I don't know what was that. That is something. Something is falling. Some code went down. Okay. Okay. This is the particle effect. Particle effect. I was actually wondering what was this. So we will search for new C sharp script, no? We created C sharp script. They called Unity C sharp script. Right. So we will be writing here public delegate void my event handler message and use a semicolon. Always use a semicolon. If I end it without semicolon, it will give me an error here. You can see the red mark. But if I use a semicolon, the error will be right. So it's telling me that it's basically a mom telling you to have a lunch. Right? So always see that you use the semicolon. Public event. I can just copy this. So this is how delegate is written. This is how you declare an event, right? And raising an event is different. To raise an event, you have to write a different code. Right, public class, my class, and public event my event handler my event semicolon, always use semicolon. Right, this is also okay. It already has a declaration my class, so I will create it as here. Just change the name and it will go away. So always use semicolon, right? And we were raising an event, right? So this is done. Use public void with so this function and remember always use semicolon. Like your mom telling you have food. Right? So this is done. Right. So this is how you raise an event. Handling an event is different. To handle event, you create a method that matches the event delegate signature and attaches to the event using the operator. Right? Handler syntax is different, and always use events to decouple objects and enable loose coupling with a consistent naming convention. For events, for example, like I have used my event. If I don't use it, it will give me errors. So always use a consistent naming convention, right? And use naming convention for event handler as well. It's in my event handler. is the event handler, so use the consistent naming convention and avoid using events for very complex logic. Not for very complex logic. Instead, use them for notifying other objects or other game objects or other, you know, scripts or to notify them of changes or events without having them related to each other, right? So by mastering this event delegates, you will be able to write more flexible, scalable and maintainable code in C Sharp. It actually comes very slowly and some people still suffer still suffer from it, even after 2 3 years. So don't stress yourself. You will eventually get there, and you will eventually be able to use event and delegate. And then we have abstraction class, override and overload. I will be telling you that shortly. To keep this model short, I think it's already more than an hour. So let's see.